Hello everyone and welcome back to my channel. Today we are working again with Wavetable daughter boards. You can see here this is the WavetablePi project. You can find this at Scrap Computing's GitHub. I already used this to build this Wavetable board that has a Raspberry Pi 02W and it can emulate the MT32 as well as general MIDI, so it can load sound fonts. I started this project because I wanted to test the hanging note bug on my Sound Blaster 16 card. And there are already two videos on my channel. The first one is to figure out what the hanging note bug actually is, and we tested two games. One was Hexen. In this game you can reproduce the hanging note bug quite easily, and the other game was Doom, which is more of a random occurrence of the hanging note bug, but it is way more prominent. So yeah, the hanging note bug in Doom will be annoying, whereas in Hexen it kind of adds to the flair of the game, as some of you commented below my previous videos. And in the second video we actually fixed the hanging note bug by replacing this chip. So if you want to have a look at both of these videos, please go ahead and watch them, they're already on the channel. In order to trigger the hanging note bug, I needed a Wavetable daughter board. This is an external MIDI device, and this is utilizing the MPU 401 and causes the hanging note. But this PCB is a little bit cumbersome to assemble, and you can see it is a multi-layer assembly here, which will block the adjacent ISA slot. Now I tried to solve this by creating my own PCB, and this you can see here. It is called the MIDI FORGE, but this specific board here is called the Maestro in the MIDI FORGE lineup. Most of the components are identical, but I also added some buttons. I added a header for a breakout cable, so if you wanted to, you can connect a cable and bring the LCD screen as well as these four buttons to the front panel somehow. This connector for the breakout cable is compatible to the front panel assembly that you can get at Serda Shop, if I pronounce this correctly. So you should be able to use the MIDI Forge Maestro with one of these front panels. And it should also support the rotary encoder. We will test this maybe also as well in this video. But this video will mostly be about assembling this PCB, testing the sound quality, because I did notice that there is an issue with this assembly here. Every time the Raspberry Pi is reading from the SD card, you may get some noise on the output. So there is some distortion you basically can hear when the Raspberry Pi reads from the SD card. I wonder if I was able to fix this on this PCB design, but well, we will see. There are some extra components here, some extra capacitors that are not really available on this board, but I'm not an expert. We will just try and hear if this PCB is a bit more quiet than this one, specifically when we are reading from the SD card. Of course, we will test all the buttons. We will try to connect the rotary encoder here as well. But I already have a bug on this board, and this was a viewer pointing it out. I think I connected the buttons incorrectly, so we have to check this under the microscope and verify how the button is switching. So essentially which pins are being shorted when we press on the top of the button. So this will be a video where I'm mostly assembling this board and then testing its functionality. And at the end, I will let you know what my plans are for this PCB. Today's video is sponsored by PCBWay, who also fabricated the PCBs of the MIDI Forge Maestro. Once I sort out the tiny bugs we will find today, the PCBs will go up on PCBWay's shared project space. It is super simple to get your PCBs from PCBWay. Select the number of PCBs you need, pick a color, and you're ready to place your order. PCBWay also offers other services like CNC machining, sheet metal fabrication, 3D printing, and injection molding. So, if you're in need of a partner for your next projects, please check out PCBWay.com. Links are in the video description. So let's start by looking at the PCB and verifying something that one of you already said about my button layout here. It looks like I connected these pads wrongly. So here's a button that goes on these pads, and the trace connects these two pads, and on this side is ground. You can see this because we are connecting to this big plane here, and this is ground. So if I take my multimeter now and probe ground, so these two are connected and these two are connected. So right now the PCB connects these two pins. and they are not connected. However, what is connected are these, and so is the lower pair. So that means this button at this stage right now is always on. This is a little bit unfortunate because now I need to, well, drill into this very nice PCB and reroute the traces. I am going to cut for each button. I'll cut the trace here. And then I also have to separate this pad from the ground. So yeah, this is a little bit messy, but there is nothing else I can do. That was just an oversight. I think I got sidetracked by the schematic that I have seen somewhere on the internet, and yeah, unfortunately, I didn't pay too much attention. My fault. Okay, so now let's see if each pair is still connected. This one looks pretty cut. Yeah, this one also good. This one also separated. Cut. Good. 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 And good. But obviously I don't want to leave it like this. I will apply fresh solder mask to plug all these holes that I created in the PCB. Time for a little bit of sun. Okay, so this is hopefully fixed now. We'll be able to solder the buttons on this board. I tried to make this a single slot expansion, but unfortunately with a Raspberry Pi, I think this will be still a 2-slot card. What I decided on doing is I took some low profile pin headers. I think they're only 3.5 millimeters in height, and so is the corresponding male header. Now you could go ahead and use an SMD pin header, just a male one, and solder the Raspberry Pi directly on to this one, and you could save a little bit of space, because with this option obviously you have two plastic distances. One is from the header and one is from the socket, whereas with a male header you will only have this distance. The problem with the male header only is that your Raspberry Pi will be permanently soldered to the MIDI FORGE Maestro and you will not be able to get it off. And on top of that, we still have an LCD, which also will be higher than the Raspberry Pi, and the DAC, which also is higher. So you would need to get for all these connections a male pin header only. Anyway, I will go ahead with a higher solution. I will solder this socket here, and then we'll just work our way through and bring all the components to this board. If you have a better idea how to get a Raspberry Pi on this board, let me know. Maybe there will be a better solution than having these tiny pin connectors, but this is the best I could come up with right now. The nice thing about these pin headers here is that they're all SMD soldered now, so the other side of the board is completely component free. There is no solder connection, there is no pad, nothing. So you will not accidentally short anything on your sound card. Now, for those of you who want to get one of these Maestro boards, I will try to make them for you. So if you are interested in buying one of these, you can always let me know and then we'll figure something out. I'm also in the process of creating a store on my Patreon account. This makes it just easier to have everything in one place, and I don't want to set up another e-commerce solution, so I think I'll just utilize Patreon for that. And you can get a fully assembled board. Recently I've seen that Tony's 90-degree adapter is being sold on eBay. Maybe it will happen to these boards as well, I have no idea. But I will add a small QR code at the back of the board, so you will always be able to find who is the original creator. And if you want to support the original creator, you can just purchase a digital certificate on my Patreon account. Okay, so the pin header here is already nicely soldered to the board. Now let's continue directly with... let's start with a few SMD components. So we need two tantalum capacitors here. These are 22 microfarad. So the tantalums are in place. Those resistors build a simple voltage divider for a MIDI output signal, I believe. I think it's the MIDI signal that comes from the sound card, which is most likely a 5-volt signal. Maybe it's a little bit lower, but it's definitely higher than 3.3 volts, which is the requirement for the Raspberry Pi. That is why we have here a voltage divider. This is the DAC section, so the digital to analog converter, and I tried to separate ground planes here, so you can see here a very nice groove around the DAC area. If you look at the pinout of wavetable headers, usually you will see that one section of the ground signals is for the analog section and the other side is the digital ground. I tried to separate this, however, I think all of my sound cards that I have tested so far, they're just connecting these two grounds together. Anyway, just in case there is a sound card that does that separation, there is a separate ground plane for the digital to analog converter. Also, the digital to analog converter connects this ground. So here is a ground and here is a ground pin. So here is a ground pin and here's a ground pin. This section also connects to this ground, which is the input right now. This is the output section, and you see all these vias going through, and if you look at the back, it's one big copper plane, and we are definitely connecting this ground with the analog ground here, analog ground. So this is just one big section. So yeah, if the sound card doesn't connect them, this device will. When I built the WavetablePi, I thought it was a little bit noisy, and here is a sample. This is just what I noticed when I was playing the intro of X-Wing. Every time the Raspberry Pi was loading data from the SD card, you could hear it. Basically, there was some noise distortion coming through the speakers. And I thought this has something to do with a DAC, and that is why I created an LC filter here. This is just an experiment. I don't even know if I'm using the correct values. Anyway, I have here a 22 microfarad capacitor. It will be the main component that is responsible for delivering a stable voltage. Then we go through an inductor. For this scenario, I picked a 10 microhenry inductor. And then here we have another 100 nanofarad capacitor. But please let me know in the comments if I'm using values that absolutely don't make any sense here. But anyway, if you look at the DAC, it has a lot of components as well, and I'm pretty sure that there are many components that are used for power filtering. So I think we'll be fine, and whatever I designed here doesn't have that much of an impact. I thought the noise that I could hear every time the Raspberry Pi loads something from the SD card was because the power supply to the DAC was not clean, and that is why I added these components. But as it turns out, it was my sound card. I have this ESS audio drive, which seems to generate this noise, but only on the left channel. So there might be something wrong with the sound card. I then tried the WavetablePi on my Sound Blaster 16, and the output was completely clean. So it has to be the fault of the sound card. Now, unfortunately, since there are pads, we have to populate them, because if I don't put this inductor there, then the circuit is not working. So we need some flux and a soldering iron with a little bit of solder. There you go. Done. Now let's add the coupling capacitors. What is that? I also had to read up on that. So you can see here we have the left channel that comes out of the duct and the right channel, and we go in the capacitor. And if you look at the capacitor here, so we have one side that goes to ground and the other side is on the plus rail, basically the voltage supply. And what happens is that it gets charged, and once it's fully charged, no more current is going to flow through this component. Now, on this part, as you can see here, this may look a little bit weird, because if the capacitor doesn't let any current flow once it's charged, what does it do here? Well, this signal is not a direct current. This is alternating current, so it goes back and forth. And this is going to pass through that filter. It's basically our audio signal that goes up and down if you would look at an oscilloscope. It's not like a battery voltage that's a constant 1.5 volts, for instance. So why do we need coupling capacitors here? They are going to block DC voltage. So just in case there is some direct current that would flow back to the sound card, this capacitor is going to block it. And then only our alternating signals are going to be passed from the duct to the sound card. And that is why we have these two capacitors here. What's left? Oh, the buttons, and well, we have a pin header here. I also noticed that the writing here on the silk screen is going to be covered by the plastic of this pin header. So what I will do is I will add the same markings on the back of the board, so you will always be able to identify which pin is which. So yeah, these are prototype PCBs. So last time somebody asked me why are you using always flux if you're soldering fresh solder? And the reason is, well, most of the time I just get better solder joints. That's the whole reason. If I don't use flux, the solder doesn't flow into, like for instance here, between the pad and the pin. The solder always flows into the direction with the most heat. And that is why you see me sometimes touch the pad instead of the pin. So let's see. You see the solder is slowly making its way across the pad. Now I can just touch the pin, and now the pin is going to be hot and I can just solder nicely the entire pin here. Let's push this down. Okay. So yeah, it does work, but I prefer having some flux there because it just makes the solder joints nicer. This wire, this solder wire, does have some flux inside. You see there is a small hole in it, and this is where the flux lives. There is a tiny hole with flux. The only downside with flux is that you have to clean it afterwards, and that's sometimes a real pain. By the way, if you're interested in getting these Maestro boards, or one of them, as a kit to solder yourself, we can also arrange that. Most of the things we'll discuss then via email, what you want to do with this board, and we can even do some customizations. Not necessarily with a PCB, but how to assemble it. Now this spot is for the LCD. For fixing these components, it's always better not to use a ground plane because it is just so much harder to get the solder flowing. And then if you need to rearrange them somehow, you're struggling moving this component left and right. Whereas if you have only a small trace like this one, it's super easy to get this fixed. This is pretty good. Yeah, so this one took a lot longer now to melt. But I think this is good. Also here a little bit of flux. This makes it also run under the pin, between the pin and the pad, a little bit easier. So, okay. If you look through this opening here, you will see how the flux is going to go over the entire pad. Let's see. Oh, you see it a little bit moving in there. There you go. So, and now let's just reinforce these two. So the pins are on the DAC, but now we need to make sure that when we solder the sockets to the PCB that they are having the correct distance or the correct orientation where the rest of the pins here line up with. And that is why I basically attach the sockets here now. And now we can go back to our board. And here's the DAC. And it has to be aligned like this. So now we can see here are the two pins from the output. These are the two ground pins. And here are the pins for the power input and the MIDI data and everything. Now we can look at our two ground pins here. We need more heat for these two because they will connect to a larger ground plane that's under the DAC. Okay, so now these ones are on. Now only half of the pins are connected, so we have to be a little bit careful removing the DAC. There we go. Now we can solder the rest. Okay. So, DAC module is done. I will not show you how I soldered the pins on this Raspberry Pi because this is 40 pins and we already saw 40 pins today. Let's finish with the buttons and then we can finally have a look at, well, the screen, which also still needs the pin headers here. I'll also do this off camera. Yeah, and then we will see how this module looks like and if it works. That was the last button. Okay, so I will finish up the soldering work, which is basically I have to add the wavetable header here. I have to solder the Raspberry Pi pin header and the screen pin header, but I think we have seen enough today. And then we can test if it works. And here's what we have built today. Here is the main board, the MIDI FORGE Maestro, where we can connect our Raspberry Pi to. We have the DAC connection. We have the LCD or the OLED display. Yeah, it's LCD here, but it's an OLED display. We have the buttons to switch the synthesizer, cycle through sound fonts or ROMs for the MT32, and we have volume controls. And then I also added the wavetable header. So all that's left is we have to assemble the board. So first we connect the Raspberry Pi. And then we will add the LCD, but let's get rid of this screen protector. Okay. And finally, our duck. So this one should fit now nicely in here because we had the measurements taken. And there we go. So here is the assembled board. Now, of course, they are lifted because of all the plastic connections here. And unfortunately, this is going to obstruct the adjacent ISA or PCI slot. So it is a little bit unfortunate, but there is nothing I can do right now. But maybe I will try to assemble this board in a different way in the future. So now let's put this on my ESS audio drive. And yeah, so here's the pin header. Done. And here is the MIDI FORGE Maestro connected to my ESS audio drive. What is left is the SD card. I already copied the MT32Pi project on there and reconfigured it so that we use the simple 4-button interface. So yeah, you need to do this, otherwise the buttons will not work. And we have to add that SIM card into our Raspberry Pi. So now we are ready. Let's test the card. Moment of truth. Let's see if this MIDI FORGE Maestro board is going to work. Okay, good sign. And MT32Pi is showing up on the display. The system is booting and we loaded the sound font. Let's quickly test the general MIDI implementation and run Xwing. So yeah, this MIDI daughter board seems to be working. But now let's check out the 4 buttons that we added. I will change the synthesizer. We will go from general MIDI to MT32. That should work. It will just sound a little bit different. And we immediately changed. And now we are in Roland MT32 mode. Let's set up Roland with Sound Blaster. I think that would sound a lot better.
Move our Star Destroyers within range and launch all TIE Fighter squadrons.
Now we should be able to switch from the old ROM, which is the default setting on the Raspberry Pi right now, to the new ROM files of the MT32 with a second button. And I think we changed to the new ROM files. Let's see. You can loop through the ROM files of the MT32 and the CM32L, I believe.
Launch the X-Wing fighter.
You can loop through all the ROM files, so you can go from old to new to CM32. It's great. So let's remain on the old ROM files, but now let's increase and decrease the volume.
Got it. Nice shot, Rick.
Okay, volume buttons don't work. Interesting. Let's change the synthesizer and go to general MIDI. Maybe this only works in general MIDI. Okay, now we're back in sound fonts. Yeah, here we can change the volume. Oh, the buttons are wrongly labeled. This is volume up. This is volume down. I made a mistake. Did I? Let's quickly check the documentation. Yep, button 3 is volume down and button 4 is volume up, so it's just wrongly labeled on my PCB. Okay, this will also be fixed in the next version of this board. But now what I want to try is I want to try this board on my Sound Blaster 16. And we will also use the rotary encoder. This should make it a lot easier to change the volume. So this is something you can find on the MT32Pi project. This is well documented, and yeah, let's see if this works. It's basically just a dial that you can turn and you should be able to control the volume. It also has a button, but this is at the moment not implemented. But you could also go ahead and reroute one of these buttons for the button press here. I just ignored it for now because then I only have to deal with 3 wires. So what we have to do now is, and this is where the problem comes in, now I don't see where the connections are. So I'll use another board to figure out where we have to connect. Okay, and this is it. So I hooked up the rotary dial. But before we can use that, we need to modify the config again for the MT32Pi project. Because now we are no longer using the 4 buttons. Now we are using the rotary encoder. So yeah, the rotary encoder works. That's super cool. Now you have a physical knob to adjust the volume of your MIDI playback in games. Okay, and this is all I have for you in this video. But now the question is, what is my plans with this board? Because it's clearly not ready. So I'll be working on revision 1.1. And yeah, once the boards are verified and tested, I will announce it in one of my future videos. So if you haven't subscribed to my channel, then I highly suggest you do so. I will also make an announcement on my channel's community page. So I hope that everybody who is interested in one of these boards will know it. Then you will be able to either order these PCBs from PCBWay, or you can go to my Patreon shop and buy a completely assembled board or a DIY kit if you want to solder it yourself. I have a feeling that these boards will end up on some classified websites in different countries, and that's perfectly fine with me. But what I will do in revision 1.1 is also to add a QR code at the back of the board. Then you can just scan the QR code, go to my Patreon account and buy this digital certificate for the MIDI Forge Maestro. So this is really for people who want to support my work and got these boards through other channels but not me, and help with development of future projects, because I have a feeling that there will be some very cool boards in the future. And even though I'm not an expert, I absolutely love designing PCBs somehow. I really enjoy it, and I will learn along the way. And of course, as always, I'm interested in your opinion. What do you think about this project? Would you be interested in getting one of these boards? Would you be interested to get an assembled one and try out my Patreon shop? And what color would you prefer? Is it just the simple green one, or would you prefer a different color? I was just thinking maybe it is a good idea to have different colors available. And yeah, this is it. Thank you so much for your time. Thanks for watching. I hope you enjoyed today's episode, and I hope I will see you in one of my future videos. Take care and bye bye.
Got him. Follow me. I can't take him. I'm on him. Nice shot, Red 2.